Okay, now the first important thing is atom, and for that, actually, for I will just show you my an atom. Okay, the first thing is that so many scientists came in and they come up with different type of you know atomic model which comes in their mind. Initially, the scientists were thinking that the smallest entity of an element is atom. That's from start, very much start. They were thinking like this. But as the time progresses, different models are coming in and coming out. What here we are talking about is the latest model. I will let you know what exactly is the result and where this actually model comes up. Actually, initially there was a plum pudding model. Initially, that model is called as plum pudding model, which is not in our course. So I'm not actually focusing on that. Different models are came in initially, and then they actually a Rutherford named, I mean, one scientist named Rutherford. He actually do one experiment. Now, what is that experiment? That experiment is called as Rutherford experiment. Actually, what this model, you know, this model was like this, that he was thinking the whole of the area is a positive charge, technically speaking, and electrons, he's not considering it, or he's considering that, for example, if you got an area, let's suppose this is a whole area, you have it, plumb, you can say. He said it, all the area is covered with positive charge. Only few like some small pastry you have somewhere, you have electrons somewhere. That's what the model he was actually thinking of. And then he actually performed an experiment, and that experiment actually gives a different result what he was expecting. Now, what did he do? He actually have an alpha particle emitter, or you can say a particle or a substance which are actually emitting alpha particle. We will talk about this alpha particle later on. But first of all, remember at this point, alpha particles are the particles having positive charge. That's it for the time. Alicia, what do you think this round thing is?
Is it like an electric field or?
No, no, it's a fluorescent screen. So
Oh,
that if
okay.
anything hits to that screen, you will going to find out. Okay. So this is like that. So now important thing is in between that you can see a gold foil. All right. Now what he did, he bombarded the alpha emitter particles onto this gold foil. And you know what was the result he thinking? He was thinking that most of the particles or alpha radiations will be reflecting back. The reason is because he was thinking that in a plum pudding atomic model, positive charge are everywhere. So he may think that most of the radiation will return and very few will pass through. But the result which he actually got are absolutely, or you can say totally against what the result should be. Now, what the results are, check it out. These were the conclusions, or these were the things which actually he got. Let me just enhance it so that you will understand what exactly the results. Can you see them properly now?
Yes.
Okay, now check this out. What he was concluded that vast majority of the particle were not deflecting at all. Now this is strange because what he was thinking that vast variety of the, you can say, alpha particles should deflect back because he was thinking that positive charge are everywhere in the atom. Do you understand me? But the result is totally different. Then the second was some particle deflected through a large angle. And the third one is alpha particle repelled. Alpha particles are positively charged. Okay. Now, what are the results he actually found out? Now, check this out. If vast meta particles were not deflecting, what do you think of it? It means that inside the atom, because it was a belief from the start that positive charges are there. So if positive charges are all over the atom, then they shouldn't be deflecting back. So what he was thinking, that still positive charges are there, but at a very small area, which he gives the name as a nucleus. So what he says is the atom must be mostly empty, because if it's mostly empty, then and only then this is possible that positive charges, particles or radiations are going and they are not deflecting. They straight away hit the fluorescent screen. You understand, Alicia and Manur?
Yes.
Now, second important, some particle deflect through a large angle. It means that very small or thin, you can say, nucleus with a positive charge with large electric field near to its surface as well. Because if it deflects by chance. If any ray come in the range of that, it deflects. But very small number of particles are deflected. They are not reflecting back, but deflected. Like they are coming in that range, so they deflect and they go a bit at a certain angle. Then the next, some of the alpha particle also repelled as well. Alpha particles are positively charged, so the nuclear must be positive charge in order to create an electrostatic force of repulsion. Now, what he think at that point is, because alpha particles are positively charged, we know that. So, what they were thinking that since they are positively charged and they are repelling, it means that nucleus must be a positive charge particle. There are positive charge particles inside the nucleus. That's the reason this alpha particle or some of the alpha particle do reflect back. Now, everything is sorted except the one thing. The atoms are neutral overall. So electron must be on the outside of atom, separating one atom from the next. It means that they must be in their shells, rotate around the nucleus. So these are the four conclusions he drew from the alpha scattering experiment. Any question, Alicia, from there?
Oh no.
And what about you, Manu?
No, sir.
Is it? Don't need to write it for the timing. I will tell you how to write it. So now the model is what? The new model was, there is a nucleus, right? There is a small nucleus in the center. And if you have an atom like this nucleus has all the positive charges, all the mass is concentrated on that. After some time, then neutron is also, you can say, discovered. So we can say proton and neutron are present in the nucleus, and electrons are revolving in the shell around this nucleus due to force of attraction, because nucleus got a positive charge, so electron must have a negative charge. So that is the model which we have to discuss now. Few things which are very, very important. How does the atomic thing look like? So for that, this is the model we have it. Put a heading atom. An atom is considered to be the smallest entity of an element. It consists of, put a heading in nucleus. Write down, it's a central part of atom. It's a central part of atom made of protons, in a bracket, write it down, positively charged particles and neutrons. These two types of particles are called nucleons. They are bounded together by the strong nuclear force. Then put a heading electrons, almost massless particles which orbit nucleus in the shell. Then put a heading proton number. This is other than the atom. Atom is sorted. Now, what is proton number? The term we will be using all the time. Number of protons or electrons. Number of protons or electrons. Then put a heading nucleon numbers. The number of nucleon is the number of protons plus number of neutrons in an atom. Okay, now check it out the way this atom is actually expressed. Check it out. Now, this is the way of actually representing a nucleus here. Now, how to do this? This is the symbol. This A means nucleon numbers and this Z means proton number. Just put a heading representation of a nucleide of an atom. Nucleide is a sum of nucleus and protons. You can say nucleons or you can say nucleide means nucleus, nuclei, nucleides are the same words. Okay. Okay. Understood or any problem in this? Till now, I don't think so there is any problem.
No, sir.
Very simple. Now put a heading Rutherford atomic model. This is very important. This is a part of your course, I believe. So let's do that. Put a heading Rutherford atomic model. I've already told you in a like quick way the plum pudding model. I want you to go through this. I will not go through that because this is not a part of our syllabus. I want you just quickly, whenever you have time, go through this model, which I just told you. It means that all the atom is filled with positive charges and very few there are negative charges or electrons around. So I just quickly jump into Rutherford atomic model, but I want you to go through this plum model. A small, quick homework for you. All right. Okay. Now,
Okay.
plum pudding model, just because it is no more a part, it's all sorry, obsoleted. That's the reason. But to understand why Rutherford actually proposed this model, you need to understand what plum pudding model has a shortcomings. We will be discussing that while we have the results, right? So Rutherford atomic model. The plum pudding model, the plum pudding model given by J.J. Thomson, given by J.J. Thomson, failed to explain certain experimental results associated with the atomic structure of elements. Atomic structure of elements. Rutherford, a British scientist, conducted an experiment and based on the observation of this experiment, based on the observations of this experiment, he explained the atomic structure of elements. He explained the atomic structure of elements and proposed Rutherford's atomic model. Rutherford atomic model. Put a heading, Rutherford's alpha scattering experiment. Rutherford alpha scattering experiment. Rutherford alpha scattering experiment. Now, this is the diagram, right? And how to do this? Let's see. Rutherford in his experiment directed high energy streams of alpha particles from a radioactive source at a thin sheet of gold in bracket just write 100 nanometer thickness. Next bullet point, in order to study the deflection caused to the alpha particles, he placed a fluorescent zinc sulfide screen. He placed a fluorescent zinc sulfide screen around the thin gold foil. Rutherford made certain observations that contradicted Thomson atomic model. In a nutshell, Rutherford conducted an experiment. By bombarding a thin sheet of gold with alpha particles, and then study the trajectory of these particles after their interaction with the gold foil. I want you to draw this diagram if it will be easy for you. I'm talking about this diagram. Alpha scattering gold foil experiment. Manur and Alicia, maybe tomorrow I will not be able to take a class. So if I come early, because actually, these are Eid days, so I have to take my family outside due to some reason. So if, for example, I will come early, I will let you know. Alicia, what was the first observation? What do you think? I already spoken about this a few minutes ago.
Is it that like um it passes through most
No,
of it?
most of it
Which
actually, yeah, it passes through, not deflected, which actually indicates that most of the atom is empty, or you can say hollow. Manur, what is the second observation he just found out?
That the atom's the main mass is in the nucleus.
So basically, the observation was that whatever very few numbers of radiations are actually deflected with a very large angle. So what he was thinking, that major mass, which is a positively charged mass, must be at the center. That is the reason the alpha particle, which are also positively charged, they are actually deflected at the large angle. And very few rays actually come back, because he already know that alpha particles are positively charged. So he definitely he said definitely the nucleus, which is right at the center, mostly occupied by the positive charge, which is proton. Right. So these are the observations. So put a heading, observations of Rutherford's alpha scattering experiment. Observations of alpha scattering. Number one, the major fraction of alpha particles, the major fractions of the alpha particle bombarded towards the gold sheet passed through the sheet without any deflection. Put a small heading, conclusion. Conclusion. Rutherford concluded that most of the space in an atom is empty. Most of the space in an atom is empty. Second observation. Some of a particle deflected through, some of the particles were deflected by the gold sheet by very small angles. Very small angles. Conclusion. He concluded that positive charge in an atom is not uniformly distributed. Uniformly distributed. Not uniformly distributed. Not uniformly distributed. So, okay, suggest that there is a positive nucleus. Uniformly distributed, and there is a positive nucleus. There is a positive nucleus at the center. Third point, only small number of alpha particles, only small number of particles are deflected through large angles. Conclusion, there must be a very small nucleus with a positive charge, with a large electric field near to its surface. Some alpha particles repelled as alpha particles are positively charged, as alpha particles are positively charged. So, conclusion, nucleus must be positively charged. Nucleus must be positively charged in order to create an electrostatic, in order to create an electrostatic force of repulsion. Next point, atoms are neutral overall. Atoms are neutral overall. Overall. Okay, you done. Separate one atom from another. Okay. I want you to draw that diagram as well. This one. Not the above one, but this one. Sorry. The one, this one. Any question related to this experiment?
No, sir.
Very simple. That how everything is actually working on this. Now, another very important topic, because there are some more things are actually a part of it, which I will dictate you later on. Just leave a space of one page actually. And then we will proceed with something called radioactivity. What is meant by radioactivities, Mahanur and Alicia? Yes, what do you mean by that? Okay, what happened actually? Now I tell you. You know, those atoms whose atomic number is more than 91, 92. There are some naturally occurring radioactive elements as well, but I am for the time being talking about those having a natural tendency of being radioactive. Now, if you can think of it, if 92 atomic number is this, or you can say proton number is 92, you think so about that there are 92 altogether protons and 92 electrons in that atom, or one atom will be quite big, because nucleus, we already found out that nucleus is very small. So nucleus is not stable as well. Plus multiple electrons, 92 electrons in one atom. So, you know, if there are 92 electrons, what do you expect? Is that atom be stable? Especially those electrons who are quite in the outer shell. Definitely, that particular atom or that kind of atom will no longer be a stable atom. So, what happened? Natural tendencies or natural God gifted, you can say that these particular elements or nucleus, they are actually they will continuously radiating energies or different type of materials or radiations. They emit them out and they convert themselves into a stable nucleus, a new nucleus or new element, you can say. This phenomena of converting themselves into stable nucleus by actually disintegration or by actually decompose themselves by radiating different element is called as radioactivity. Okay. Okay. Now I Actually, the space you already left with, I want you to put a heading, Rutherford atomic model. The one you left with, let's complete it. Rutherford atomic model. After getting these observation down, now he proposed a model. Now what is it? Let's see. First point, the positive charge and most of the mass, the positive charge and most of the mass and most of the mass of an atom is concentrated in an extremely small volume. In an extremely small volume. He called this region of an atom as, he called this region of the atom as, Alicia, what do he called it?
Sorry, can you repeat the question?
He called this region of the atom as very small volume, where major mass is concentrated. Yes, Manu?
Nucleus.
Nucleus. Second point, he proposed that the negatively charged electrons, the negatively charged electrons surround the nucleus of an atom. Surround the nucleus of an atom. He also claimed that the electrons surrounding the nucleus, electron surrounding the nucleus revolve around it with very high speed in circular path. Very high speed in circular path. He named these circular paths as, he named these circular paths as orbits. Third point, electrons being negatively charged, electron being negatively charged and nucleus being densely concentrated and nucleus being densely concentrated, mass of positively charged particle, mass of positively charged particles are held together, are held together by a strong electrostatic force of attraction, are held together by a strong electrostatic force of attraction. Now there is a small topic, or there is a small, very small topic related to that. what are the limitations of Rutherford atomic model, which is also a part of our syllabus as well. Students, is there any issue during this all?
No, sir.
Anyone? Alicia?
No.
Okay. Alicia, after this alpha, beta, and gamma rays, definitely we have to do uh, radioactivity, then alpha, beta, gamma, and then we will have equation related to alpha, beta, gamma as well. I think this is a
Okay.
topic you're talking about. Is that the one?
Yeah, this is the one. Yeah.
This is only
Like
ended up.
all this.
Yeah, definitely alpha, beta, gamma, their equations,
Yeah.
radioactivity, and that's it. There is nothing else, or there is anything else.
No, I think that's it.
But this is very, very important what we are doing right now, especially
Yeah.
line spectrum is a part of this one or the waves one.
I think
That's
that's waves.
yeah.
Is it a part of waves, right?
Yeah.
Yeah, because they are
It's
all
actually
talk.
photo.
Yeah, these topics are all mixed up at one point. That's the reason you cannot differentiate which topic belongs to which part. Because when you're talking about radiations, then these radiation also a part of quantum physics as well. Because photon, when you change everything into photon, actually these are all called photon things. Light is actually emitting in some way or another. If inshallah once you go to your universities, you will find out that actually this is all leads you to quantum physics. So there is no special segregation of the topics, but definitely that's the reason I keep on asking you what topic, I mean, which paper this particular topic belongs to and which paper the other topics belongs to. Because in your paper, the topics are different, but as a whole, these waves, radioactive waves, quantum physics, they are all mixed up actually. All right. So for tomorrow, maybe I will not be able to take the class as I have told you. If I'll message you first and then there will be a class. Okay. Otherwise, in the next few days, after the Eid, inshallah, I will compensate your class. But the rest of the days, the class will be as usual. Manur, what day the Eid day at your place where you live?
I'm not sure. I can check.
There will be two possibilities. So what are those? In Pakistan, the
It's
possibility, yeah,
9th of April, Tuesday.
Tuesday. So Tuesday or Wednesday, right?
Yeah.
In Pakistan, we can have Eid on Wednesday and Thursday. So let's see. Whenever there is Eid, definitely Eid day there will be off. You know that. Okay.
Yeah.
So hopefully not the tomorrow one, but after that we will have our routine classes. All right. The old timetable, Manur, the timetable we were following previously before the Ramadan, that will be followed right
Yeah.
after the Ramadan, inshallah. I will share with you the same timetable. I kept that timetable. I think you already know that it's 11 o'clock. We have our class at Pakistan time.
Yeah.
So Alicia, you have to follow the same one. Okay,
Okay.
this same time anyway. Time will be same, so don't worry about it. Okay, then see you. And as I told you, this recording is already available, also available, so you can take that or you can hear it if any of you having any problem or difficulty in understanding this topic. All right. Okay, then see you. Bye.